if we could achieve time travel, what will you see? Then our universe will be very different. Today, we are about to embark on a journey through time, now to the distant future. 18 years later, equivalent to 1 billion years. That's a huge number. Let's take a look at the future 1 billion years from now. And something terrible is going to happen. 1 billion years later, the Earth will become unrecognizable. The once vibrant blue planet. Now it's a dead brown. Colored rocks and changes in the sun has taken all life on Earth. The sun is getting hotter and hotter. Temperatures rise by about 1 degree every 100 million years. The current surface temperature of the Earth, it's 47 degrees centigrade. That's 117 degrees Fahrenheit. This rise in temperature upsets the carbon cycle in the first place, caused plant death. And then the animals went extinct. There may still be some life left in the ocean. But as the temperature rises further, water evaporation, once beautiful planet, it has now become a dry death rock. I can only hope humans back then, before the sun destroyed us, has left the Earth, established colonies elsewhere in the galaxy, but certainly not on Mars, because even on Mars, too close to the sun, humans need to live farther, possibly in other galaxies in the Milky Way, or the outer planets of the solar system or their moons, will temporarily become suitable for us to live in. The once populous Earth will become a distant memory. There is another possibility. Some humans may take the form of pure artificial intelligence. The formula continues to exist. The person who uploads his consciousness to the machine, it can be almost forever. Live in a virtual way. But these machines that carry them, it needs to be somewhere. There is some kind of energy supply, so humans in physical form will still exist. Build these colonies to keep our virtual humans running. This is just the beginning of this journey. Let's push forward billions of years. You will see that the sun is much smaller than it is now. It's about the size of the Earth. It's also white, much darker than before. Over the past 9 billion years, the sun burns all the hydrogen in its core. When his shell starts to burn, he became a red giant. Eventually, as all the fuel runs out, he reached the end of his life as a star, becomes a white dwarf in his red giant stage. The tremendous energy released by the sun caused its outer layer to expand, swallowed Mercury, and possibly Venus. The Earth has been evaporated, stripped to his tin box. The sun will cool for billions of years, then reach his next stage, a black dwarf. When the sun goes out completely, another major event is also taking place due to the attractive force. Andromeda Galaxy, 400 million kilometers toward the galaxy. Two massive galaxies merged. Rocky planets and entire stars will continue to be pulled by attractive forces, and this will continue for millions of years. When the two galaxies finally merge, he has a new galaxy named Mikomi. You thought the stars would collide in this merger, but it's unlikely because the distance between them is so great, hundreds of billions of kilometers apart. Scientists have calculated that our solar system has a 50% chance of being pushed away. The core of the galaxy, 3 times farther away than where we are today, there is still a 12% chance. Our solar system will be completely ejected from this new galaxy. If humans were still alive, we will definitely choose one that will not experience merging galaxies. Farewell to the Milky Way. Keep pushing the time machine. After 22 billion years, things started to get a little more complicated. What will happen is called the Grand Commander. According to one theory, the universe will tear itself apart. This will be caused by dark energy. This is something that physicists don't understand at all. But they do know one thing. He caused the universe to expand faster and faster. If a major tear occurs, galaxies and clusters of galaxies that exist today will start to stretch each other. Star system, planet, everything will accelerate away from each other. All the way down to their atoms, they will tear apart and dissolve, leading to the end of the universe. Scientists have discovered some evidence. We may be headed towards this demise. But that's not 100% certain. Suppose the universe doesn't rip apart in 20 billion years. This doesn't mean that our universe will be safe. In 100 trillion years, all the stars in the universe will be extinguished. Let's go back 150 million years after the Big Bang. Stars are born. The rule for stars is that the smaller the star, the smaller it is. The longer you live. Look at this star. It's 8% the mass of our sun. He's too young for light fusion. So he's a brown dwarf. And this big one, about 10 times the mass of our sun. He burns even hotter, and it consumes its fuel very quickly. So about 20 million years later, he will extinguish. You have seen our sun about 10 billion years later. But most of what you see is constant. The stars are smaller than our sun. These are infrared stars. They're about 8 to 50% the mass of our sun. They have to press more, but they also live longer. About 80 to 100 billion years, you're going to start to see these red dwarfs start to die, and that leaves the brown dwarf. They died a gentle death. As they cool down, their temperature will drop to 2,500 degrees Celsius. This is cooler than most stars. And finally, let's look at the end of this massive star. He's 8 times the size of our sun. His core is collapsing into a huge explosion, created a supernova. This led to the birth of a neutron star. This is a very dense and compact star, or his death could lead to a black hole. In 100 trillion years, you have just witnessed the stellar age. You've watched the birth and death of stars, the coming and going of planets and the merging of galaxies. And when a star dies, they will release various elements and substances into space. This usually leads to the formation of new stars. But not all death is constant. The mass of the star is released and form new stars. So the universe will slowly run out of raw materials. Does this mean the end of the universe? Keep pushing time. That is, one is followed by 19 zeros years later. The stellar age is over. We are in the early stages of a new era. It's called the degenerative era. He looks much dimmer than before. It's a universe littered with the remnants of dead stars. White dwarf Sogna. Neutron star black hole. All the stars that have ever been born die. What would happen if there were still humans at this time? One possibility is that we give up matter. The body exists entirely in the form of energy. It shouldn't be the ghost you imagined. But in the age of degradation, maybe there will be a small miracle. For example, if 2 brown and dark shapes collide, he might give birth to a new star, can survive for trillions of years. Or if 2 white dwarfs collide, you might see a superstar explode. But in general, The universe is getting colder and darker. The smallest building blocks of matter continue to decay. This is me, 18 years after our stone. But what happens after that? What will happen at the end of the universe? Let's hurry up. Fast forward to the 34th power year later, also one followed by 34 zeros. The end of the era of degradation is approaching. White dwarf, brown dwarf. Even neutron stars will start to die. They will die because of a process. Become proton decay. They are the smallest subatomic particles made of them. Child begins to solve. Body and death. These white dwarfs will no longer emit a lot of light. On the contrary, they will have the brightness of just a few light bulbs. This decay takes a very long time to complete. If there is equipment, you can watch those little protons die. If the fundamental building blocks of molecules eventually decay, then the fate of the universe seems predetermined. As the proton disintegrates, we have reached the final battle, the future in 40 years. That's one followed by 40 zeros. Things are getting bleaker and bleaker. There are no planets. There are no stars, no dwarf stars, except for a very faint flash. You can hardly see anything. These are black holes. Some scientists refer to this era as the beginning of the black hole era. Black holes would be the most massive structures in the universe. They devour anything that comes close to them. Devouring the remains of dead stars, it gets denser and bigger. The only way to escape, just a tiny radiation leak. This is called Hawking radiation. That's how he works. Twin particles keep appearing in space. Immediately drown each other. Sometimes one falls into a black hole and the other one escapes over trillions of years. This particle leakage would reduce the mass of the black hole, cause his death. And that's a long time. The last moment. Let's see what happens next. Recognize the future in 100 years. That's one followed by 100 zeros. Welcome to the Dark Ages. The last black hole in the universe lost his quality and die at this moment. There are only a few subatomic particles left in the universe and dark energy. The universe is expanding so much so that there are very few subatomic particles left, very far from each other. In the entire region of our current universe, to see a single submolecular particle, what a sad and lonely place. Remember to press energy. He will continue to expand the universe further. As the universe continues to expand, it cools down. Scientists refer to this stage as the Great Freeze. All the energy in the universe will be evenly distributed. The temperature will be slightly above absolute zero. It was very, very cold. This theory of the universe has a rather dark ending, but there is another theory. It's called greedy shuttle. Rather than infinite expansion, the universe has reached a point. He turns in reverse and starts to contract. It's like rewinding the video from your old age back to infancy, and then an embryo, and then a single cell. If that develops, then maybe the entire cycle of the Big Bang will begin again. Or maybe it all happened. We are in the midst of many expansion and contraction cycles. One of the midterm. Unfortunately, scientists think that's unlikely. It seems more likely that the universe is governed by dark energy, the end of the Great Freeze, even setting aside the Big Freeze. Once we enter the age of degradation, life in the entire universe looks rather bleak. And we need bright, glowing stars to create habitable zones. Life on a planet. So how do we make this a reality? Remember that humanity is only 200 years away from the Industrial Revolution. If I only said if, Centuries later, as humanity progressed from the first type of civilization to the seventh, civilization-like novels, trisolarance can create independent space if it can be achieved. That's another story. Please leave a comment for discussion.